Okay, so we're going to do our quick review before we jump into the problems. So solve the quadratic equations using the given method. This was done earlier in algebra, but it's okay if you forgot. We will go over it again here. Okay, solve by factoring. So if you remember, the first step for factoring is we need to get everything to one side. So right, we need to set it equal to 0. So we bring that over, we have x squared minus 3x plus 2 equals 0, right? We move this 2 over. And then we need to find two numbers that multiply. Okay, so first we have to realize there's no variable in front of here, right? So we need two numbers that multiply to 2 and add to negative 3. So that would be negative 2 and negative 1. So we have x minus 2, x minus 1 equals 0. And then to solve it, we need something that says x equals. So we set these equal to 0. And we see that x equals 2 and x equals 1. And you can always double check it by plugging it back in, right? So if I plugged in 1, I'd have 1 minus 3 equals negative 2. If I plugged in 2, I'd have 4 minus 6 equals negative 2. So hopefully this is a quick review. If not, really take in those steps and make sure each one makes sense. Another way, so this is a good way to check. Another checkpoint is you can FOIL this out to see if it matches, right? So we do FOIL minus x minus 2x plus 2, x squared minus 3x plus 2. That matches. So we know that we factored it correctly here. And these are our answers. Solve by double factoring. Okay, so first we always want to do the greatest common factor. I forgot to mention that over here because there was no greatest common factor. But here we can see that we can pull out a 4. And we're left with x squared minus 1 equals 0. And so that was the first factor, and then we factor this guy. So this is difference of squares. Hopefully you remember that. So we have 4, x plus 1, x minus 1 equals 0, and then we solve it. So for this one, it's x equals negative 1. For this one, it's x equals 1. Okay, and then another double factoring. We pull out our greatest common factor, 2. We get x squared minus 9x plus 20 equals 0. And then we factor this guy, 2. It's going to be x minus 5, x minus 4 equals 20. How did I get those two numbers? Remember, multiplies to 20, adds to negative 9. Since it needs to add to negative 9, we for sure need a negative number. And since it multiplies to positive, these both need to be negative. So we have negative 4 and negative 5. And then we solve these and set them equal to 0. That means x equals 5 and x equals 4. Okay, hopefully that was a review, but I understand that factoring can be tricky for some. Just try to follow these steps. And if not, feel free to look at a past lesson or look on Google or YouTube for factoring, because factoring does not go away. Okay, factoring is super important. Okay, into the meat and bones of this. Right, a good way to do this is to make our chart, right? So we have x and x squared, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. X squared, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Okay, so this one is actually quite easy because it's already a perfect square. So we know that this is negative 6 times 10, or negative 60. If you gave me this, it wouldn't be the final answer. You need to get me to the final answer. You need to fully simplify, right? Okay, this one, 6, and then we keep our radical. 32, if we want to look here and see if there's anything that's divisible into 32. And we can see right here we have 16, right? So we have 16 times 2. We can rewrite that as 6 times the square root of 16 times the square root of 2. which turns into 6 times 4 times the square root of 2. And finally, we get 24 root 2. Okay, here, 125, is it divisible by any of these things? It is divisible by 25. So we have a negative 5 times the square root of 25 times 5. And you can use a calculator for that if you don't know it off the top of your head. We rewrite that as negative 5 square root 25 square root 5. This guy turns into 5. Negative 5 times 5 root 5. And then we finally multiply those together. Negative 25 root 5. Okay, on to 4. 150. Again, we can use 25. This turns into 5. And then it simplifies to negative 10 root 6. This one is already a perfect square, 6. So we have negative 4 times 6, and that turns into negative 24. This one, let's see. So we sort of want to start, we can always start, here's a good tip, talking over myself. We could start at the number closest to 54, but below it. So 49 doesn't work, 36 doesn't work, 25 doesn't work. 16, does 16 work? 32 plus 16, no, 16 doesn't work, and then 9 works. So we go 5 root 9 times root 6, right, because 9 times 6 is 54, we have to keep the root, but then this guy we can finally turn into a 3, so 15 root 6, whoops, not root 16, root 6 is our final answer. Okay. 20. So we're going to start at 16. Nope. 9. Nope. 4. Yes. So negative 2 root 4 root 5. Negative 2 times root 5. Negative 4 root 5. Okay. 32. Start at 25. Nope. 16. Yes. 4 root 16 root 2. 4 times root 2. 16 root 2. And if you haven't noticed, I've skipped a step already. So here I broke it down and I said root 16 times 2, and then I split them into their own roots. Here I'm just automatically splitting them into their own roots. So if you like breaking it down like this because you want to see each step, that is perfect. Keep doing that. If you like to do this because you like to take shortcuts and you can still do it accurately and correctly, do that. You know, there's some ways where you could do it even faster, but I'm just showing you these ways and just to make sure that you're getting it. But if you could find something even shorter than what I'm doing and it's correct, go for it, right? Okay, 216. You know what? I'm going to use my calculator because I don't know. Okay, so 216. Let's check 144. I already know that's not it because it's more than half. 216 divided by 121. I don't think that's it because that's an odd. We know that it's not 100. Let's try, I don't think it's 81. Let's do 216 divided by 64. Nope. 216 divided by 36. There we go. So we have to, don't forget this negative. It's going to mess some of you up. So square root of 36 times square root of 6, negative 6 root 6. Okay. Okay, let me do 13 real quick, and let me show you what happens if a common mistake. Okay, so let's say I did 180 and I didn't start up here. Let's say I was just like, oh, I know that's divisible by 4, right? I know 180 is divisible by 4. So I'm going to do 4 first. So I have 2 times root 4 times root, what is 180 divided by 45? And I do this, right? 2 times 2 root 45, 4 root 45. And I'm like, oh, I'm done, right? Wrong. You are not done because it's not simplified. Okay, so this 45 can be broken down even more. So I could turn that into, right, this is divisible by 9. So it'd be 4 root 9 root 5. 4 times 3 times root 5, 12 root 5. So that's the tricky thing with these. If you pick the wrong value, like if you don't pick the bigger value on this chart, you have to keep simplifying. So make sure that this number inside the radical is not divisible by any of these guys, right? Because if it is, then you're not done, okay? And then you'll get it wrong because it's not simplified. Okay, let's go back to 10. So 30, not divisible by 25, not divisible by 16, not divisible by 9, not divisible by 4. That one's actually a trick question. This is already simplified. Okay, 125. So we know that it's one, we did one similar up here, right? So we have 6 times root 25 times root 5. And then we know that this is 6 times 5 times root 5, 30 root 5. Okay, this one, 144 is automatically 12, so negative 5 times 12 is negative 60. 4 root 18, so we have 4 times root 9 times root 2. 4 times 3 times root 2, 12 times root 2. 8 is divisible by 4, so 3 root 4 root 2. 3 times 2 times root 2, 6 root 2. 64, that is already a perfect square, so it's 5 times 8, 40. Okay, 32, we have 16. Let me do another one where we chose it wrong, right? Okay, so we do 5 root 4 root, what's 32 divided by 4? 8. Then we do 5 times 2 times root 8, 10 times root 8. You think you're done? No, because we can keep doing 8. So we have 10 root 8. Wait, I just wrote the same thing. That can be 4 and 2. 10 root 4 root 2. 10 times 2 times root 2. 20 root 2. Alright, let me do the rest of these even quicker. So this is root 4. Negative 2 root 4 root 3. I already know in my head that's 2. In my head I'm going to multiply by negative 2. Negative 4 root 3. So here I skipped another step to make it even quicker. Again, if you don't like skipping steps, if you like writing everything out, that's completely fine. Whatever you like, as long as you get it right. You know, each person does math in a different way, and it doesn't mean that one way is better than the other. Okay, 216. I'm going to bring out my calculator again. Oh, wait, no, I already did it up here. 216 and 36. So we have negative 4 root 36 root 6. Negative 4 times 6 is negative 24 root 6. Took another shortcut. Negative 6. Oh, we already did root 30. We knew that it wasn't anything, so just right there. And that's it. So a lot of different problems, a lot of practice, but that's the whole thing. We practice to get better, right? Think of a sport. You can't just jump into a volleyball game and expect to be at your best, right? You want to practice. Okay. Last page. This is the application and extension. Simplify the following radicals. We just did this. Okay. So 48, we can split that into 4 and 12. And that turns into 2 times root 12. We're not done though. This 12 can be broken up even more. So 2 root 4 root 3. 2 times 2 times root 3, so 4 root 3. So I actually chose the wrong number. I should have chosen 16. I should have done 16 times root 3. But it's okay, as long as you keep simplifying, yeah? Okay, and then this is 36, so 8, 36, 2. 8 times 6 times root 2, 48 times root 2. Okay, now the word problem. The perimeter of a square is given by the function p equals 4 times the square root of a. Find the perimeter of a square that has an area that measures 225 meters squared. All right, this one's a little tricky, right? So whenever you see anything that like can be drawn, I always recommend drawing a picture. So we have this picture of a square. We know the perimeter is p equals 4 root a. So if you think of the perimeter, how do you find the perimeter of a square? You have to add all the 4 sides. But we know that the 4 sides are equal. So this is actually giving us a hint. It's telling us that the perimeter is 4 times root a, which means that every single side is root a. Because it's a square, so they all have to be the same. Right? And so they want us to find the perimeter. So they want us to find p. of a square that has an area that measures 225 meters squared. So we need to find A, and then we need to find P. So the area is going to be the two sides squared. So root A times root A equals area equals 225. So root A times root A is the same thing as A. Actually, that's not a good way to solve it. It's not false, but it's not a good way to solve it. Okay, so we know that root A, we need to find root A by itself, right? So root A times root A equals 225. So we want to figure out two things that are multiplied by each other that equals that. So actually, yeah, let me go back. So we have A equals 225, and we're trying to find the square root of A. So we need to take the square root of 225. So the square root of 225, you should know, but you can also do in your calculator. Square root is right there in the blue, so you have to do the second button. 225 is 15. So we know that root A equals 15, and remember, this one's tricky because we found root A, so we think we're done, but they actually want the perimeter. So we need 4 times root A. So 4 times root A, which is 15, which is 60. And let's do units, meters. We always want units. So if the area is meters squared, the perimeter is in meters. Okay. The time t in seconds it takes for an object to free fall a distance d, right? So this object is falling d, right? Always draw a picture. Is given by this function t equals 1/4 root d. This assumes no air resistance, of course. Find the amount of time it would take a 25-pound bowling ball to fall a distance of 16. So we know that we need t, and we know the distance is 16. This 25, Liz, is a trick. It's a red herring. Nowhere in this equation does it talk about weight, so we don't need this 25 pounds at all. All we need is the d, right? If we want to find t, all we need is the d, the distance. So they gave us the distance, which is 16. So we have 1/4 times the square root of 16. We know that's 1/4 times 4. 1/4 times 4 is just 1. So 1 second. We always love units. 1 second. All right, last one. Let's do some awesome graphing. Fill in the table of values and graph the points. Okay, so 0, the square root of 0 is 0. But let's check. Square root of 0. So ideally you can do this without a calculator, but if you need a calculator, that's fine. Square root of 4, we should know that's 2. Right, square root of 4. Square root of 9 is 3. Square root of 16 is 4, 5, 7, 8. So they skipped 6. And then they want us to graph it, right? So we have x, root x. So this root x is the same thing as f of x, right? So let me do it in a different color so you can see. We have x, our x-axis, which we're used to, and this is our y-axis, but remember, it's labeled as f of x. So f of x, these are all the same things. So it's essentially xy, but it's technically f of x. Okay, so we have 0, 0. We have 4, 2. 4, 2. We have 9, 3. 9, 3. We have 16, 4. 16, 4. We have 25, 5. Finally, we're on a line. We have 49, 7. 49, 7. And then we're at 64, 8. 64, 8. Okay, so we're going to keep graphing this. And we're going to just put a little arrow because we don't know what else is there, but we know it keeps going on. Okay, look at that beautiful graph. What is the domain, right? We did that, domain. Domain is all possible x values. Okay, so this is different. Before, it was just points, but this is a line, right? If you see f of x, that means it's a whole line. So you can't just list off the points. We need specific values. So the domain, right? Domain is the x values. What is the lowest x value? The lowest x value, we're only looking at this axis. The lowest x value is here at 0. And then the highest x value, right? Right now we can only see 64, but we know that it keeps going, right? If this graph kept going past the screen, it would keep going to infinity. So the domain is going to be x is greater than or equal to 0, right? It has that little line there because this is a filled in circle. And then what is the range? So same thing. Now we're only in y value, so now we're only thinking up and down. So what is our lowest? Is going to be 0. And our highest? Oh, that's really messy handwriting, but that's like what my handwriting looks like. Highest? This one's harder to see, right? If this keeps going, it's going to keep going up. It's not going up as fast as it's going to the left, but it's still going up, and it's going up forever. So the highest is still infinity, right? So this is going to be y is greater than or equal to 0. If you've learned interval notation, you could also write this for both of these. Both of these are correct. If you didn't learn one or the other, that's fine, but make sure you have either this or this, and then you have either this or this. So that is domain and range. So those are all the problems. Hopefully you were able to do some on your own, but it's always nice to make sure that you're doing it right. So please email me if you have any questions, and nice job.